Hi, in this tutorial we are going to talk about how to find the exit from a maze. For example, we are given a certain map where the number 1 denotes the wall, number 2 denotes the start, and number 3 is the exit of the maze. And we want to find a solution to this problem. And how can we solve this problem? With the help of depth first search. The so-called Tremao algorithm relies heavily on depth first search in order to find a solution from the start node to the target node or the exit, whatever we call it. So in this situation, there's a lot of paths from the start, the number 2, to number 3, so we definitely can find a way out. And I have implemented this. First of all, we have to create a file reader. This is a class, this is a custom object. I mean, we have to specify the path of the file we want to parse, and we have to give the number of rows and the number of columns. It's pretty straightforward. We just have a map. It consists of integers because we have zeros, and of course zeros, if I'm not mentioning, 0 is the path in the maze, so we can go towards 0, but we cannot go towards 1 because that denotes a wall. Okay. So first of all, that's the constructor. We initialize the map with the number of rows and number of columns, and the parse file is pretty straightforward. We are going to create a scanner. We are going to create a file. We have to create try-catch blocks, and for the scanner we have to read as many numbers as the file contains, so the number of rows times the number of columns, so it's a double for loop. We just read the integers with the help of scanner.nextInt, and if the map ij is equal to 2, it is the starting position, so we store the start position column index and the start position row index, of course. I is the row index. Okay, it doesn't matter because it's symmetric. I mean, the number of columns are equal to the number of rows, whatever. And there's a method getMap, and here we are going to parse the file, and we have a maze solver. We initialize it, instantiate it, and find a way out. So how does it look like? It's just a simple depth first search. We are going to have private fields, start position column, the start position row. It is the start position, so the column index is 0, 1, because it is in the second row, and the second has the indexing of 1 because we start from 0, and in the first row, because that's the 0 column, that's the first column, so 1, 1 will be the column index and the row index of the starting point. And to find out, we just have a try-catch module, and we just have a depth first search, and yeah, we have a depth first search, and here it is the column index, and that's the row index, and that's the column index, and we check whether the maze map ij is equal to 3, which is the exit of the maze we are looking for, and if it is, we throw a new runtime exception, which means that this is going to be called, and by the way, this is the solution is not found. So we're just going a depth first search. We have to check whether if it's visited. Of course, we are not going in that direction because we have already visited it, so we return. We have to check the boundaries, so the row index is less than 0, it cannot be less than 0, and it cannot be greater than the end of the map. Of course, we have to return. We have to check it for the column, so the column index is less than 0, or it is greater than the end of map. Of course, we have to return. And if it's a wall, it is equal to 1. As I said earlier, the 1 denotes walls in this map. Of course, we have to return. And else, we set the visited map to true in order to be able to detect whether we have to visit this region or not. And we go down, we go right, we go left, and we go up recursively with the help of depth first search. That's what we are looking for, but here we have to go in 4 directions: up, down, left, and right. So basically that's all. And if I run this, we are going to have the solution. I'm going to print out what kind of places we are visiting with the row index and the column index. You can check it. And RouteNet find. And it is correct. Oh, no, it's not correct. Yeah, route found to exist. So route found definitely, because we can go from 2 to 3. But if I put a wall here, it means that it is blocked. So we should get, if you run it as a Java application, no solution found. We keep iterating lots of places before reaching the conclusion that no solution find, and so on and so forth. So with the help of this algorithm and with the help of depth first search, we can get out of the maze, or we can find out whether there is a way out from this maze. So I think it's pretty straightforward application of depth first search. If you are interested in, it's quite as a physical topic. Percolation theory relies heavily on quite the same topic with depth first search, and we have to go down, right, left, or up. And by the way, it's not that important, but this how to get out of the maze. I think it's a pretty straightforward and a very interesting application of depth first search. Thanks for watching.